Welcome all. Today we're going to talk about the lessons we learned while migrating 3000 openvz containers to CloudStack. I'm Jeffrey Kriegsman, Senior System Engineer for Leaseweb for the last 13 years. Working at Leaseweb, last 3 years in the CloudStack team. With me is Tyler Wilson, DevOps Infra Specialist for Leaseweb. You can tell a little bit more about yourself.
I've been working for Leaseweb for about 4 or 5 years now. I was previously with OpenStack, and now I've been indoctrinated into CloudStack, and lived it ever since.
Okay. So we work for Leaseweb. Leaseweb is a global hybrid hosting company. We're currently located in 21 data centers around 4 continents. We've been in business for 20 years, and we're offering services like dedicated servers, co-location, VPSs, cloud hosting, both public and private. So the agenda for today. Today we're going to talk about why we migrated 3000 openvz containers to CloudStack, the migration methods we found were suitable to actually migrate these containers, how we ended up migrating them, how we migrated the network between our platforms, a little bit about policy-based routing to get the network, the VMs in the network running, and the lessons we learned while doing all of this.
So I'm going to talk about how we migrated all this stuff. First of all, the context of how everything is happening here. Leaseweb acquired a company called Servant in 2018. Then one of the objectives there is to migrate all of their stuff into Leaseweb's infrastructure, so we don't have to manage 2 different platforms. And Servant was obviously a web and managed hosting cloud provider, so more of the same kind of things that Leaseweb does. So we want to just align all those services into one infrastructure there. The goals there is to migrate the data for the customers in question, keep the downtime as minimal as possible, keep their current IP address so they don't have any kind of sort of downtime for their customers, and automate it as much as possible since it is 3,000 plus containers, since a lot of work to do manually, and still be able to use all the CloudStack features as normal after the migration.
So the source where all these containers are coming from 2 platforms that were running at Servant. One parallels Virtuoso 6 platform that had 3,000 containers running, and one parallels Virtuoso 7 platform that had about 250 containers running. So we migrated these machines to our Leaseweb CloudStack platform, which we built fully redundant, high available, including NetApp attached storage, full flash for performance. Network all redundant, power redundant, make sure that everything stays up and running in case of a failure. Migration methods. So we investigated on how to migrate the containers from openvz, from the Virtuoso platform, to CloudStack. We came up with 3 possible solutions. One was a container to virtualization conversion. Since most of I think about 90-95% of the containers were actually running cPanel, we looked into the option to do cPanel to cPanel migration. And of course, there's always the option to give the customer its own method of migrating its own data. So the container to to VM migration. So the idea is what we will do is we will create an exact copy of the customer's container and then deploy it in a virtual machine. The advantage is that there's no customer action needed, so we do everything for the customer, copy the data, bring it back online. For us, it means, since we don't want to work a lot of manual tasks, means a lot of automation for us. So for us, it will initially be more work to actually do the automation, but then all the migrations itself will go automatically. We are reliant on existing tooling to perform these tasks. And we must support legacy operating systems. The containers were running from different operating systems, from CentOS 4 all the way up to the latest CentOS 7, Ubuntu 10 to Ubuntu 18. And all these methods or OSs needed to be supported. For us, this was the preferred option to do the migration, since that would be requiring the least amount of work for the customer itself. The other option we investigated was a cPanel to cPanel migration. So here we will deploy a new VM on the CloudStack platform, and then Leaseweb support will do the migration between the cPanel control panels, where they will migrate the data, do initial migration, and then change the DNS records to possibly new IP addresses. An advantage for the customer to do the cPanel migration is that he will get a new machine, meaning latest OS, latest updates. And if the customer still had an old OS, then it means more security for him as well, since it will have the latest patches. However, as I said, it's about 95% of the instances that had a cPanel running. That means that there are still some machines that will not be able to be migrating this way. And then we have the option of the customer migrating its own data. In this case, we will deploy a new virtual machine on our CloudStack platform. We'll give the customer the credentials to this new machine, and then the customer could migrate the data between his old instance and his new instance himself. For us, it means the least amount of work, since we just have to deploy a new VM. However, there's a high chance of client loss, since for the customer, copying his data from one machine to another machine, if it's within Leaseweb or with a Leaseweb competitor, for the customer it's the same amount of work. So for us, this is the least preferred method.
So I'm going to talk about the different migration strategies we did. First thing we tried was there's a utility within Parallels that is called P2V or PM Migrate. Initially, this was the preferred option because it was the one suggested by Parallels as a proprietary tool. But it wasn't really built for KVM migrations. It was built for Parallels VM migrations, which is actually a different kind of thing. But we tried it nonetheless. We found it mostly unreliable. It did migrate things sometimes. Otherwise, it would just give a vague, error 51, error 48, and we'd have to call support. It had a pretty long execution time. Some VMs with 30 gigs would happen within an hour or so, but some would take days because customers had quite a few files, inodes, and it had to tar all those inodes up. It used a local disk space on the hypervisor. It used a temp partition, so it limited our use case basically to stuff that had enough disk space within the hypervisor to store the VM again. It could only process one container at a time per hypervisor, just the limitations of the process. Didn't really support any kind of parallel processing. And we still had to process that image to be compatible with the CloudStack environment. So we still had to upload all of the DHCP hook scripts. We still had to configure all the interfaces as a normal migration would. I'm going to talk about the process flow for using that tool that we found out here. So first we just executed the process there. We transferred the Parallels VM disk image on the source hypervisor, so the hypervisor storing those containers. And then we converted that Parallels VM to KVM via the QEMU image tool, which does have support for Parallels VM and KVM. So in theory, it would be able to work, but I think that's assuming no other issues. And finally, we find a free NBD disk on the mount image. We have a working hypervisor. We upload that to. We mount that converted KVM disk. And then we use GuestFS to detect the OS. So some of these were CentOS, some of these were Ubuntu, and we need to figure out programmatically which one's which, without going into the OS and digging through files. And GuestFS was able to do that for us. Then we backed up the existing configurations files because we didn't really want to overwrite anything that would break something. So we backed up the network configuration files, boot settings, yum configuration files, anything we changed, we backed up first, and we wrote new files according to our new CloudStack environment. So that's everything to do with OS, repositories, file system settings, boot settings, everything. And then finally uploading the CloudStack DHCP hook scripts to get password reset functionality working, to get SSH keys working, all that fun stuff. And then finally registering the HeHo template and starting it with the IPs of the original VM had. And then after dealing with this tool for a number of weeks, I finally went to the drawing board again and found my own method of doing this through rsync. It was quite a bit faster than pmigrate or P2V. By the order, it was exponentially faster. Within 30 minutes, I could get a container to a CloudStack. It was developed entirely within Leaseweb, and it used entirely, I think, all open source software. It had minimal downtime. Before, with the P2V tool, the container was down as soon as the tools ran. Now I can sync all the data, and then on the second, I can sync it twice, and the second sync is obviously offline sync, and it'll cover all the missing data. It's tailored to support each specific OS, so it's a little more work, but it ended up being a little more reliable for us because we could actually tailor a tool for each OS. And we could reuse all the code that we used for the CloudStack image preparation, so all the configuration files we rewrote, all the DHCP hooks we uploaded, all that stuff could be rewritten, or reused, sorry. So the process for the rsync is a little more complex, but along the same lines. First, you have to install the kernel and grub packages on the source container. For openvz, they actually don't really use a real boot sector bootloader, and they also don't really use the same. They don't use their own kernel for the VM, and like we do on CloudStack. They use the hypervisor kernel, so we have to install that, even though it's not going to boot from it yet, while the container is still running. Make sure that succeeds. And then on our converter boxes, we create a raw disk with the same container size using GuestFS. Again, GuestFS, amazing tool. You can create a blank disk just as a QEMU image. And then we convert that disk to a QQL2 image, and then we mount that using NBD. And then we start the rsync process, and that will sync all the data from the live container onto this empty disk there. And then finally, the downtime starts, and we stop the container and resync the data to cover anything missing. This process usually is much shorter. Now, the downtime started, we detect the OS via GuestFS. Again, we need to see exactly what version of CentOS, what version of Ubuntu it's running to write the specific network files and all that stuff. I back up the existing configuration files again, and this is the code that we reuse. And we wrote the new CloudStack environment. And then this is something we actually had to add is writing our own, executing the inner MFS and creating the kernel environment with all the VirtIO drivers that CloudStack needs. And that was dependent entirely on the different type of version of the OS, because Ubuntu, CentOS, and all the different versions do this differently. And then again, write the CloudStack DHCP hook scripts to get the pass-through resound functionality working, SSH key support, all that stuff. And then the same thing, uploading the keycow template, and then starting the IPs from the source container. Now, there is a special caveat to this. We found we had a CentOS 7 working box as a converter box, and it did not support really the older Grub installation. If you ever have to work with Grub 1.0 and then having a newer OS install Grub 1.0 for an older OS, it never works almost. So what we ended up doing is I created a custom ISO that booted into a CentOS 5 environment, or 6, one of the two, and installed Grub and the kernel drivers needed, and then rebooted itself automatically. So if the version is CentOS 4, 5, and 6, it changed the OS type to IDE, so it could boot it from the older. It didn't have any kernel drivers at the moment, so it booted from the older auto grub ISO. Then it changes the OS type to VirtIO SCSI, and then boot from the VM disk. So after the auto grub ISO installs the grub, installs the kernel drivers, it reboots it back to VirtIO SCSI because it has those new VirtIO drivers, and then it calls back to our migration manager, and then says drop to complete. Now, because we had so many issues with the original P2V migration, we decided to start with a smaller batch. I think this is a good strategy to employ to all projects. You always want to start to the smaller batches to make sure you get all your bugs fixed before you start taking large swaths of servers offline. But we started with 10. It seemed to be a good number. And then we ended up doing about 200 at a time as soon as we started to get the ground rolling. And to recap, originally we did use that Parallels tool, but it wasn't really sufficient for our needs, and we ended up building a total own solution out of just open source tools, which is always preferred. And Jeffrey's going to talk about the network migration.
Yeah. So network migration. So the source network existed out of about 100 subnets, different sizes, /24, 23, 21. All these subnets were divided over 4 VLANs. And one of the challenges we had was that IPs from multiple subnets and VLANs were all used on single instances. Which I'll explain later on how we solved that challenge. So for the network interconnection, the network migration, we created an interconnect between the servant network and the Leaseweb network. We used the wave-linked, basically a shared path over a dark fiber connection between the 2 data centers. Here, over this network, we created a layer 2 network with some VLANs. We used this to transport the VLANs between the 2 sites. And we also used this to do some VLAN mapping. Because servant used certain VLAN numbering in their network. We used VLAN numbering in our network, and they overlap. So therefore, we had to renumber some VLANs on the servant side to a different number on Leaseweb, so we would not get a conflict there. So this is an image on how the network connection looks like. We have on the left side the hypervisors on the servant network connected through a router and the internet. On the Leaseweb side, we have our cloud platform as well, connected to the router and the internet. And we created a wave connection between the 2 routers on both sides. This is how the traffic flow looks like. So traffic on the existing virtual machines within servant that were not migrated yet would still connect to the internet through the servant router. And all the machines that were migrated will also connect over the internet interconnect towards the servant routers and enter the internet there. After the migration was completed, we disabled the interconnect, and from there we switched the gateways from the servant routers to the Leaseweb routers. Started announcing the traffic for these subnets on the Leaseweb side, and then all the traffic would flow to the internet over the Leaseweb uplinks. For the VLAN remapping, we use this wave connection also for the VLAN remapping. So this is an example on how we did it. As you can see on the left side, we have one switch that has 2 VLANs, which are connected to another switch over one link with a trunk. So both VLANs will be transported over this link to the new switch. On the Leaseweb side, we connected the switch with 2 separate links to an additional switch. And here we sent the link untagged over the line. So we gave both sides the port and access mode, where on the one side it will have, in this example, VLAN 10 will be untagged over the link to a new switch, and here we will tag that VLAN again, or the network again, with a new VLAN number. What this example is for 2 VLANs, but yeah, depending on the amount of cables you pull between your switches, you can do this up to 48 ports switch, 48 VLANs. That depends a bit on your need. So that's the way we translated the VLANs. An additional feature we built is the CloudStack multi-NIC support. We talked about this a little bit yesterday in our presentation. So because the instances we migrated had IP addresses from multiple networks, multiple VLANs, the multi-NIC support was built in with security groups. This allowed us to add multiple IP addresses from the same subnet on one interface. And we were able to add multiple network interfaces to the same virtual machine, each from its own VLAN with its own network addresses, including having the support for the firewalling of the advanced security groups so that customers could still allow certain ports on each network.
So in order to get this working with multiple IPs on multiple interfaces with multiple IPs and multiple gateways, you actually have to implement what's called as policy-based routing, which is news to just some people. But it's basically used to make routing decisions based on the policy set into the configuration. It's designed for multiple network interfaces on different networks, and inbound packets are to be returned to the configured interface, not just ETH0, but whatever. If you have a packet outbound from ETH1, it'll come back on ETH1 if it needs to. And in order to configure this with CentOS, which was our primary target for doing this, you have to actually add each interface to the RT table's IP route configuration. This will create a table for each interface, which we'll be configuring later. Right now. Next, you have to add the gateway routing configuration. This is in CentOS. This is actually a route-eth configuration file, so ETH1, ETH2, whatever. And the configuration here is default table ETH0 by ETH0 gateway. Obviously, you replace ETH0 gateway with your gateway there. And the table name is right there, and that's the same one you added to the RT tables file. And again, you need to add this for every interface you have. This will define the gateway which traffic should route through for that interface. Next, for each IP on that interface, and we had quite a few IPs, you actually have to add an alias file or alias rule file, and that's rule-eth whatever interface you have. So from IP address 1 table ETH0, again, that's the same table in the RT tables file. And that is in addition to the normal configuration files you'd have to write for the interfaces in CentOS. So the if config-eth whatever. And this will get your gateway routing correctly through the right interface, which we had to do in order to get this working.
So the lessons we learned and the mistakes we made so you don't have to. The first one is get a proper test environment. We set up initially a test environment to test the migrations. And we received the test hypervisor with Virtuoso. We set up a test CloudStack environment. Started to convert with this P2V tool from Parallels. Started to convert the machine. It writes the converted disk on the local hypervisor where the container was running. And then we copied it over. However, in the end we found out that the source hypervisors where the container was running were not all the same. Some of them had hundreds of gigabytes of free disk space, others had 5 gigabytes of free disk space. And then we tried to convert a container where it tries to write locally and there is no disk space. Well, that will give you into troubles. After 5 gigabytes filling it up, it will have a full hard drive and then your migration would stop. So make sure you check this before you start the migrations, so that everything is covered.
So one thing I need to stress is you should try to use open source tools whenever possible. There's a lot more community support around them. And do not use Parallels P2V for KVM conversion. I'm sure it works fine for Parallels VM for conversion, but I would learn from this and would not try to use that. Again, the reason why we promote open source tools is because there's always a community backing it. There's always if you can see the source code, obviously, but you can actually get support a lot quicker actually out of the community than you can usually out of vendors. I found, but yeah, that's what
one lesson we learned while creating the interconnection between the two sites is that make sure when this link has been set up that the routing policy on your routers is also correctly updated. The first batch of migrations we started to migrate after 5-10 minutes after our start, we received a call from the network engineers in the US telling us what we were doing. They saw uplinks being congested. They backed loss on the links. And after a short investigation, it turned out that the data was not migrated over the internal link, but over the public internet links, which is not a good way. Carrier traffic costs a lot of money. So make sure your routing policies are set up correctly before starting the migration. And this prevents uplinks congestion on your network.
So one thing we tried to implement while I was trying to figure out in the process between setting up the rsync method and the PCV method is setting up the file system transfer locally via NFS, because I was running into issues where hypervisors didn't have any disk space to actually convert this process. So what I did was just try mounting an NFS mount on the local hypervisor itself, and to in place of that temporary directory. And what happened was ACL problems everywhere, basically. And I'm sure this is possible, but it's just not really recommended, I say. I recommend just using rsync whenever possible, because it's really designed to transfer file systems, or just straight copy the disk if you can, but that really wasn't an option for us. And don't be afraid to automate with GuestFS and GuestFish. GuestFish is a part of GuestFS. But GuestFS is one of my favorite open source projects. But it allows you to modify disk images, to modify and automate anything within the virtualized environment. It'll set up a virtualized environment for you. It'll detect your OS. It will upload files to a disk. It will pretty much do anything you want to do with virtualized environments. GuestFS can do it.
Yeah, another lesson we learned is when we started to import the templates on our new cloud platform, is that you should not be confused when after 30 minutes of uploading this data, it suddenly stops. By default, CloudStack has some global settings specifying the maximum upload size for your templates and the maximum storage volume size. Make sure that you change these settings to the needs you have. So check which sizes your largest file is. Make sure you update the settings accordingly. Because we had a huge surprise after the first upload. Like, it gave us an error message that said, upload failed. And I was like, okay, why did it fail? After inspecting the log files, we actually noticed that the storage sizes were the problem. So make sure you check this before you start migrating data. Another lesson we learned was secondary storage volumes and the way these worked. All the templates, converted containers we started to upload were uploaded as a template, which means they were uploaded to the secondary storage volume. After a few uploads, our volume got quite big with uploaded data, and we ended up adding more secondary storage volumes. CloudStack has this nice button, add secondary storage. You can just add as many as you want. We added a few more, ended up creating 10 secondary storage volumes, and we started our upload. The problem we found out here is that when you start an upload and you have 10 secondary storage volumes, the file will be downloaded 10 times and will write 10 times to each different volume, which gives you a bottleneck on your secondary storage VM, because it will handle all these downloads. The uplinks on the secondary storage VM will start to congest. The downloads will start to slow down, and it will give you eventually very poor performance on your cloud platform when deploying secondary storage VMs here. What we ended up doing is removing 9 secondary storage volumes again, and after we imported the template or a machine and deployed the machine, did the deployment with this machine, we ended up throwing away the template again to make space for new uploads. So one of the features we have on our backlog for our programmers to work on is to actually have the secondary storage volume work in the same way as the primary storage volume. That means when a download is triggered, the secondary storage VM should actually look at which volume has the most capacity available and should just save it once on that volume. So that's a nice feature we want to add in CloudStack.
So the thing we found out is that when we had to upload all of these container templates, right? We modified them. We uploaded our scripts. We changed the configuration files. We installed Grub, all that stuff. So we had to upload all these things to our CloudStack. And we found out when you're doing this en masse, some of the secondary storage VM issues were brought to light. Basically, the internet isn't perfect, right? We have timeouts, we have TCP drops, we have just connection drops, and we found there's a percentage of these will just fail on the secondary storage VM. the download would just time out, and we had to go in the database and actually just manually error these out. There was no really ability to retry the retry the upload there, and that would be something another feature we'd like to have into CloudStack. So another thing we are probably going to look into. Since, again, this is not really a normal use case, since you usually just upload a small ISO or a small, template, but we're talking multiple hundreds of gigabytes here. But it would be good to retry that upload, or at least a set number of retries in the global configuration. That'd be nice.
Yeah. And then the last lesson learned is that the conversion time for the secondary storage VM by default is really slow. We started to upload the templates, deploy from virtual machines from these templates, and our downloads. Our secondary storage VM was hosted on our hypervisors, which have 20 gigabits of internet connection. Using the VirtIO driver, we should be able to get reasonable speeds, at least up to 10 gigabits. But we saw that the downloads were going at 100 to 200 Mbit. And after looking into the secondary storage VM, we found out that the deployment size was, I think, 1 core and 265 megabytes of memory, or 512, I'm not exactly sure. But it's a really low amount of CPU resources and memory secondary storage VM has. And if you give it a lot of tasks to do, these resource settings are just not enough. We ended up shutting down this machine, upgrading it to a 16-core VM with 16 gigabytes of memory, turning it back on. And when we started the new downloads, they all started to download at max out at 10, 15 gigabits. So make sure when you start to really use your secondary storage VM and you do need the performance to increase the resources for this, you don't have to do 16 gigabytes of memory and 16 cores like we did. We had it available on the platform, so we thought, yeah, why not? But make sure you adjust it to your needs. That's it. Any questions?
So I missed the beginning, so I might have covered this. Was this a one-off migration, or is this something you need to keep?
Initially, it was for this project. So Leaseweb bought Servant in 2018, and since we want to standardize on one cloud platform, we migrated it from this company, its open virtuoso platform, to our Leaseweb CloudStack platform. So in this case, yeah, it is a one-off. However, if Leaseweb decides to buy another company in the future, we could reuse most of the methods and code, depending on the platform which that company has. So yeah.
You've now effectively got a toolkit.
Yeah. So we can, yeah.
Do you consider pushing that back out to the wider community?
In the current state, as is currently, probably not. Yeah, sure. If there's an interest from the community to use these toolings, we can optimize it, make sure we add some bug fixes, and then publish it, for example, on GitHub. Yeah.
I think absolutely.
Yeah.
There's a lot of people doing a lot of work around ingestion, bringing different things into mouse.
Yeah.
It's one of the areas that needs a lot of new functionality.
Yeah. Yeah, we have all the code in our internal Git repository. So yeah, we can clean this up and then publish it. Yeah.
We actually, I used the code to integrate dedicated servers into Leaseweb or into CloudStack as well. So pretty much if I can rsync it, it'll work within obvious data limitations of your converter box and all that stuff. But yeah, it's something that would be really cool to do for the project, for the community. Any other questions?
Okay, thank you.